Hi, welcome to the Neuro Revision Lab. This time we're going to take a look at atomic structure and the periodic table, specifically in actually using a periodic table, which many students have always found to be quite difficult. First thing you're going to need to understand is the particle model of matter. After all, we're dealing with atoms which make up the particles which substances are made of. You're going to be able to use a periodic table by recognizing and labeling key groups on the periodic table. You're also going to be able to identify group and period numbers. We will spend a little bit of time making sure that you can annotate and label a periodic table effectively. This is an essential skill and something which, once you're confident, can be done at the beginning of an exam to help you. The key words you're going to need this time are periodic table, alkali metals, halogens, noble gases, transition metals, groups, and periods. Take a little bit of time to practice spelling and sounding out those words, making sure you listen to how they're used, and you can research the definitions later as part of your ongoing revision. The periodic table that you're going to be using in your exam is a stripped down version. Only the necessary groups are on there. For instance, the lanthanides and the actinides, which are two large groups which you can see on other periodic tables, they're missing, as you won't have anything to do with those. In the center, there is a key, which gives you the relative atomic mass, atomic symbol, and atomic number. It's not a very clear key, but each title in that box is laid out in the same place as it is in the periodic table boxes, so you can look to that as a useful reference. Now, when it comes to GCSE exams, you will absolutely be given a periodic table. You should be given them in your mocks as well. So if you haven't been given one during your chemistry exams, make sure to raise it with whoever is examining you, as you are entitled to have one. That being said, it will be required to be used in at least one question. Quite often, it is several. That periodic table is also your periodic table, so you can draw on it, write on it, highlight it as you see fit. And a really big giveaway when you're setting your exam is that your exam will probably prompt you to use it by saying something along the lines of, use your periodic table to answer. And finally, no, you are not required to memorize the periodic table in any way, shape, or form, but you should know how to use it properly, which in our case will involve knowing how to label it so that we can use it more efficiently. For this activity, you'll probably need a printout of a periodic table in front of you. You can pick these up pretty much anywhere. They are shared scientific knowledge, and quite often they can be found in your books. If you're using one of the Neuro Revision Lab notebooks, then you'll find it conveniently on the back. First up, we need to identify metals versus non-metals. Metals all have the same shared characteristics in that they're shiny, conduct electricity, and quite often are quite strong. So of course, we want to group them together away from the non-metals, which are not quite so strong and are quite often gases and powders. Metals are typically found on the left-hand side of the periodic table, and non-metals are found on the right-hand side of the periodic table. Unhelpfully, the line that divides them is a strange stepped line, starting between boron and aluminium, going all the way down to just below astenine and radon. If you draw in a line just here, the same as I have on this one, then that should make it very, very helpful. Don't forget to label metals and non-metals above each section. The next step is to label the group numbers. They're commonly already labelled for you, but they quite often don't actually have a specific title to say exactly what they are. They start above lithium at 1 and then beryllium 2, and then there's a large gap between the transition metals where it picks up again at boron at 3, 4, 5, 6, 7, and it's generally best not to ask at this stage why group 8 is actually group 0. We'll come to that later on when we start talking about noble gases. What's not labelled for you is the period numbers. You have to be very careful here because the first row only contains hydrogen and helium, and hydrogen is quite often not sitting where you would expect it to sit. That's because hydrogen is a bit of a strange one, and it disobeys many of the rules that apply to other elements. But we need to count that first row, even though it's largely empty apart from those two. So, starting on the left-hand side, label it as 1, 2, 3, 4, 5, 6, and at the bottom, 7. These are your periods, or your rows. Now, later on, you're going to understand that the group numbers are in fact the amount of available electrons in the outer shell of an atom. And your periods are the amount of shells that those atoms actually have. That's going to become really, really useful for us later on. Don't worry about it so much now, but just know that these numbers are going to become very important later when we look at electronic structure. Now let's take a look at some of the groups you're going to have to be familiar with first. The first one here is Group 1 alkali metals, one of my favourite groups. These metals are all highly reactive in water, and they make alkalis when they do react. Some of them are really fun, and as you move down the periods, they get more reactive, and some of them even explode. Over on the right-hand side, we have the exact opposite, halogens. A non-metal, they are more reactive at the top and get less reactive as they move down. These gases are deadly. Fluorine itself is unbelievably reactive and will set fire to most things. Our last important group is Group 0, the noble gases. Some of the last elements to ever be discovered, they are completely unreactive. They don't even bond with each other, which is why they are so difficult to find, because chemically they do nothing. They happily form plasmas though, and you'll find a lot of them in neon lights. Different ones tend to glow up in different colours. Now, of course, there are other groups here, such as the alkali earth metals and the transition metals, but we're going to try and keep focusing on the ones that you're most commonly going to encounter. Once you've finished, spend a little bit of time becoming acquainted. The first 20 elements in particular are favoured by examiners, and you will commonly find the first 20 in a lot of exam questions. You don't need to memorise them though, because now we have this amazing periodic table that we can easily and quickly replicate. At this point, your revision should probably look at least a little bit like this. Remember though, this is just a guide. Feel free to pause the video and fill out anything you may have missed. Okay, so now we've got this labelled up, you should know that the next activity is going to be a little bit like playing battleships. We're going to use the group numbers along the top and the period numbers along the side to be able to locate different elements. For instance, if I were looking at group 2 and period 3, the element I would be looking at would be magnesium, which is a metal found on the left. Let's go again, but let's switch it up a little bit. I know where gallium is. Gallium is a metalloid that begins to melt at just above room temperature. It's popular amongst chemists. They used to cast spoons of gallium as a practical joke, as people would stir their tea with it only to discover that it's melted when they pull the spoon back out. When we look at gallium and we track back the group numbers and the period numbers, it's in group 3 and in period 4. Now, using this method is very useful, as not only can we find elements quickly without having to scan or memorize over 100 different elements, but it's also the foundation for being able to quickly recognize what the electron structure of an element is, which we will cover later on. Each one of these steps is foundational and will help set you up to be able to answer much more complex questions very quickly later on. Now it's your turn. This exam question is common and has several different variations, which are all more or less answered in the same way. Question 1. Complete the missing parts of this table using your periodic table. Each column represents group and period and the element. It's your job to fill in the blanks using the method we just revised. Question 2. This comes as a three-parter. Name the halogen in period 4, name the alkali metal in period 2, name a noble gas in period 5. Now, of course, you're going to want to highlight your command words. This is what your question is asking you to do, and your keywords, which you recorded earlier, and your values, which will include any necessary numbers required to answer your question. Good luck, pause the video, and we will return with the answers shortly. For more revision resources, tips, and helpful materials, please visit the Neuro Lab store. Everything here is specifically selected or made for neurodivergent learners, and as an added bonus, each purchase supports the channel, which allows us to keep producing video content. And as usual, subscribe, like, and share. Okay, so here are the answers you needed to complete the missing parts of the table using your periodic table. We will answer one row at a time. In the first row, you needed to find the element. Group 1, period 3, is potassium. In the second row, you need to find the group. Silicon is in group 4. In the third row, you are only given the element krypton, which is group 0, period 4. For question 2, name the halogen in period 4, that's bromine. Name the alkali metal in period 2, that's lithium. Name a noble gas in period 5, that's xenon. If you found this video helpful, you can pick up one of our specialist neurodivergent notebooks, designed to make learning clearer and easier. They make perfect additions to EHC plans and are not only comfortable to write on with off-white pages, but are also broken up according to the Cornell note-taking style. They can be used in school and at home as dedicated revision notebooks. Like and subscribe the channel for more SEN-focused science revision.